about being a better data scientist. The title might sound a bit cheesy. I guess if you're an already experienced, I don't know how much new information you will learn from this talk. Hopefully some, yeah. So I want to start by saying that, as many of you probably know, that just knowing machine learning usually is not enough to be to work as a data scientist. And there are other things that are quite useful. And in this talk, I want to tell you what I think is useful. And this is something I learned over my 10 years of experience working as a data scientist. And these are the career tips I want to share. So I will not go over them right now. This is just, you can see already what I'll talk about. And I'll start with the first tip: follow MLOps principles. And I want to start by asking you, what is MLOps? We have a comments section. I would like to ask you to go to that section and write what do you think, in your opinion, what is MLOps? And there is no right or wrong answer to this question. So there are many definitions and many people think of MLOps differently. So there are many ways of defining this. And I'm really curious, what do you think about that? And right now, I will need to figure out how I go and check the answers. I think I will just need to go here and see. Okay, now it looks strange because I see myself and then the screen. So I know that there is a bit of delay between when I say things and you hear them. So maybe you can just write them in the comments. So yes, the question is, what is MLOps in your opinion? And I already see a message from Patrick. So Patrick is saying that this is a way of managing the complex interactions between code, models, and data. This is a very good definition. So this is more like about process, like how exactly we put all this thing together. So then there are comments about my YouTube channel. It's not mine, it's the community's YouTube channel, but thank you. Let's wait a little bit more. I'm running out of ideas what exactly to say now. So please write something. Arpit, thank you. So Arpit says that MLOps could be defined as a process to manage the entire cycle or pipeline of developing, training, testing, and deploying models. And yeah, again, we have this process here. So the process part is quite important. I don't know, maybe I'll wait for one more answer. I don't know, for 20 seconds. If there is no other opinion, we'll go back to the slides. But again, there is no right or wrong definition. Like there are 1,000 ways of defining MLOps. So there could be many, many different ones. So I guess I don't see any other comments. Oh, there is one from Luca. Thank you, Luca. So it's a way of organizing from problem definition to monitor models in production in a way that is controllable and reproducible. Yeah, thank you, Luca. There is one more. Cool. Amruta, thank you. MLOps can be the integration of various tools and technologies to streamline the machine learning workflow, including model development, testing, deployment, monitoring, and maintenance. So all of these definitions are cool. Thank you, Amruta. I will go now to my slides. So Ganesh, thanks also for jumping in. I will give you my definition. So all of your definitions are really good. And my definition is very similar to what you wrote, which is a set of processes and best practices for bringing machine learning to production. So I think most of you defined it in the same way, just using maybe slightly different words. And here, and I also saw that you didn't really mention tools, because for me previously, MLOps was mostly about tools. So how do you exactly, like what kind of tools I use to deploy a model? Like how do I use SageMaker for model deployment? So I was focused too much on the tools, but not on the processes, not on best practices. But later, over the years, I realized that no, it's not about the tools. It's more about like how exactly you organize your work. And I want to start talking about MLOps, since we all mentioned processes here, by outlining a process for a typical machine learning project. So we start with the design phase. So at this phase, when we start working on a project, we want to understand what the project is about, like what exactly we want to solve there. What is the objective of this? Like how are we going to measure success? Is machine learning actually the right tool to solve the problem we have? Do we have enough data? Do we have the right data? Like all these things, they come, we ask them ourselves at the design phase. And here, yeah, we also express like there is a problem. We think it could be solved with machine learning. How exactly we're going to express this problem in machine learning terms? Like, is it going to be a classification problem, regression problem, ranking problem, and so on, right? So this typically happens at this stage. And then after that, we do the training phase. So we think, okay, we know what is the objective. We know that the data is there. It's all with machine learning. Let's train a model. So this is what we data scientists typically do, spend like most of the time or some time, right? Trying different algorithms, doing feature engineering, doing all these things. So the goal of this stage is to produce a model artifact, like a model that we can use to actually solve the problem that we identified in the first step, right? And then once we have this model artifact, we go to the third stage, which is operate. This is taking the model and starting using this model for solving the problem that we identified in the first place. So this is actually applying the model. Right, and at all the stages, so for example, if we take step 2, the training stage, at this stage as data scientists, we need to be able to, when we try different algorithms, all of these algorithms have different parameters, hyperparameters. Well, like we can have different pre-processing techniques like feature engineering, normalizing, all these things. And we need to be able to keep track of the performance of our models. So here we use tools and best practices for tracking our experiments. So when it comes to tools, it's things like ML Flow, weights and biases, Comet ML, like all these tools that help us track experiments. And also during the training phase, it's important to think about reproducibility. So it's not about usually just having your Jupyter notebook with the code, right? It's also making sure that the code that we produce as data scientists are reproducible. So we can take the code we have, apply it to new data, and then produce a new model, or easily re-execute it with just one click of a button, right? So, and here it's important to have this process, this job as a pipeline, so it's reproducible. So here the focus is on reproducibility, and I hope I can move it. Yeah, cool. And on automating our training and evaluation. So this is what we focus on in the training stage, right? And then after that, we produce this model artifact. Our model could be a pickle file or whatever. And then we need to start using this model, start applying this. So this is what happens in the operating phase. And yeah, so this is, we call this deployment. And for deployment, it could be like using tools like, I don't know, Flask, Fast API, right, and deploying things to Kubernetes, or creating jobs with AWS Batch or SageMaker, or using more specialized tools like, I don't know, Bento ML, or all these ML platforms that we have, for example, like Kserve, Seldon Core, and proprietary platforms, right? So once the model is deployed, our job is not done. We need to make sure this model is actually performing well in production, right? So after a month, after 2 months, it's still solving the business problem. So we are talking about monitoring this. So here in the operating phase, we focus on not only applying the model, but also observability, making sure that the model is still behaving well. So this is roughly like how MLOps how MLOps plays part in the process of a machine learning project. So we see that there is processes, they cover all the stages, like how exactly we go from the design phase to the training phase, how exactly we go from the training phase to operating phase, and how exactly we track experiments, what kind of tools we use, and how we collaborate in the team, like for example, how data scientists collaborate with machine learning engineers. So this is all about processes, and also best practices, like again, what's the best way of deploying our pipeline, right? Or creating a pipeline? What's the best way of deploying something? So for me, this is what MLOps is about, knowing all these things. And as a data scientist, what I think for us is most helpful is focusing on these areas. So we can focus on training pipelines, like how exactly we go from Jupyter Notebook to a reproducible pipeline. It could be quite challenging, and there is a lot to learn there, but this is really beneficial. So for like knowing how to use tools like, I don't know, orchestration tools like Prefect or Airflow, or more specialized ones like Kubeflow pipelines, and so on, for creating these reproducible pipelines. And then how to go about deployment. And well, maybe when it comes to deployment, I don't need to convince you that this is really important, because if we don't deploy our model, then it's useless, right? We don't apply it to solve the problems. But then there is one step that we often overlook. In my experience, often overlooked, is monitoring. So the model is deployed and it's just there, and we are just hoping for the best that it performs well. And we all know, because we're here on the conference organized by Arize, we all know what Arize is doing. They focus on monitoring, because monitoring is a really important part of the process, right? Because if we don't monitor, we don't know if our model is actually working. Like, do the predictions that it produces still make sense, right? Maybe they don't. And if we don't monitor, we don't know, right? So monitoring makes the difference between a model that is just simply deployed and working there, and a model that is making positive impact on business. So for data scientists and in general for organization, it's very important to know how to monitor. And if we want to become better data scientists, we should invest in learning more about these things, the tools that are there. And as you know, that there is this awesome tool called Phoenix from Arize. So if you didn't, go check it out. So this is a really awesome tool. So if you need to work with images or anything else, check it out, because monitoring is really important part of the process, and we need to be able to monitor things. So what you can do here? Like when it comes to MLOps. So if you're more senior, you can actually look at the processes you have and try to improve these processes, or set up, if let's say you don't have like an experiment tracking tool, or you don't use pipelines, or there is no monitoring in some projects, you can establish these processes and think how exactly what's the best way of doing all these things, and then show it to the rest of the team. Or if you're more junior, then perhaps you can ask about the processes and learn more about them, or ask like, do we actually do monitoring, and then figure this out with more senior colleagues. And then it's not enough just to have these tools, but also you can learn how to use them more effectively. And that's one part. So MLOps is quite important, and we all know that, and it helps us and the company be more effective. But there is another thing that is often overlooked. And while talking about MLOps, maybe you noticed that I kind of didn't talk much about this design phase, right? So I talked about train and all the tools we use for training. I talked about operate and all the tools we use for this operate phase. But I kind of just mentioned that there is this design phase. But actually, this is the most important step. Like, this is the crucial step, the most crucial step in the process, because if we don't do it well here, our project will not be successful. Because let's say we decide that for this problem, we need to use machine learning, and then we spend 6 months figuring out what's the best model for this. And then we deploy this model, we use all these cool techniques, we add monitoring and all that. But at the end, it turns out that the users actually don't care about this feature. They don't really need this. And it means that even though we have all these shiny tools, we have this great model, but then it's all useless. So here we really need to make sure that we are solving the right problem. And usually people whose job it is to make sure that the team is working on solving problems that actually matter are product managers. And another piece of advice, like this is the second tip, is be product oriented. Try to learn from your product manager. So for example, in my case, I tried to sit very close with my product manager, and often I would just turn to him and ask, hey, Johan, like, what do you think about this thing? So just be close with your product manager and try to help them. Like, ask them, what are the problems you're solving right now? what do you need help with? Like, can I be with you on one of these meetings? I just want to understand, like, what exactly our users are dealing with, what our team is dealing with, who are our stakeholders, like who you spend time talking with. So if you learn this from your product manager, you will see the bigger picture. You will see exactly how the projects, like these machine learning models that you work on, fit the bigger picture, like the bigger scope of the organization. And often, like when you're present with your PM on these meetings, you can learn more, right? And then you can always ask, like if somebody comes to you with a request like, hey, let's integrate AI into this workflow, into this flow, user flow, right? You can ask like, wait, why do we actually need this? Like, is it really important? So here you can learn, so this is, I would call like the soft part. We first talked about the hard part, like the technical, the engineering part. Here is more about like how what I do fits the bigger picture and how can I learn this. And with that, you can take the end-to-end ownership. So not only you as a data scientist can be involved in the training phase and operating phase, but also you can be involved in the design phase, right? And this is again the most important step, and your PM can help you with that. But you can ask me, hey, wait a minute, like it looks like you're suggesting that I should do 3 jobs, right? So I should be a data scientist, then I should also do machine learning engineering to take care of all these MLOps, and then I also need to be a product manager, right? It's 3 people, and I'm getting salary only for 1 person, right? So why do I need to do this? How is it even possible? And then there is, maybe you heard this title, it's called full stack data scientist. I don't know if maybe it's not super popular these days, but a couple of years ago it was like, I guess. So a full stack data scientist is somebody who can do things end to end. In our example, means like somebody who can design, train, and operate the model, right? And it sounds cool, but in practical terms, it means that if you want to become a full stack data scientist, you need to know product management, data analytics, data engineering, machine learning engineering, backend engineering, MLOps, and all the random things you need to do along the way, right? Which is a lot of things, right? Like how is it possible for a single person to even start thinking about all these things, right? It's pretty complex. And here I want to tell you that it's not as scary as it sounds. And I want to talk about this metaphor. So in machine learning, there is this concept called learning curves. So in this chart, you see the relationship between the amount of data we have and the accuracy of our model that we can achieve with this amount of data. So, and we see that there is sort of like, at some point, bringing more data does not mean we get, the same increase in accuracy. So we can have a good model with a reasonable amount of data, but if we want to have a really, really good model, a great model, then we need to put a lot of effort in collecting the great data set, right? And then, like, if we want to have even better model, like a perfect model, we will need to have like 10 times more data. And the same with skill proficiency, right? So instead of the size of your data set, you can think about the time you invest in learning a skill, like the time you practice this skill, right? And you can have like really great skill proficiency if you put like, I don't know, 10,000 hours in learning a skill, right? But then you can have a good skill proficiency if you put, I don't know, 1 year in practicing the skill. But then you can have an okay proficiency, like you can just get around with Google or ChatGPT or whatever by learning just a little bit of that, maybe spending a week, 1 week of your time on learning a skill. And often this okay level of proficiency is just what you need, right? So you don't need to be proficient. You don't need to be an expert. You just need to know a little bit and then ask for help when needed. And then it will give you independence. You can just move faster and do all these things that we talked about in the first 2 parts, like MLOps, product management, all that, right? So we don't need to be experts in everything, right? So it's okay not to know some things. And here I often think about these proficiencies as these kind of swim lines where we have areas, different areas, and then the depth would be something like how well we know this. So some time ago, when I just started machine learning, so I knew a bit of software engineering. So my profile looked like that. So I learned machine learning at school, at university. Then I knew a bit of engineering, and then over time, like I started doing things in practice. So I learned a bit of analytics, and then I did more and more and more. So my profile changed, and then like at some point, I learned more about MLOps. I learned more about machine learning. I learned more about analytics, and over time, my profile evolved, right? So I got more into machine learning engineering. But here, this is just an example, right? So we always learn a little bit more. Like our profiles might change, but what you want to have is this kind of T-shaped profile. So you can be an expert in one area. For a data scientist, it could be machine learning or ML engineering, MLOps, whatever. And then you just know a little bit of everything else to be sufficiently independent in what you do, right? And this is called a T-shaped profile. Maybe you heard about that. So you can be an expert in one thing and have an okay level in other things, right? So these are the two tips, right? And they kind of like, if you follow them, you kind of become a full stack data scientist. And in order to actually do this, like how do you find what you need to focus on? You can use the Pareto rule or 80-20 rule. So you need to find out what are the 20% of the effort that you put and you get 80% of the result, right? So you all knew about this thing, right? So when it comes to MLOps, for example, what are the 20% of effort you need to put to learn to be 80% effective, right? And there are ways how I approach this typically, like when I need to pick up a skill. So I take a skill, like for example, MLOps, and I break it down into different areas, different parts. And you can repeat this process. And then you order each of these skills by importance. And this is the most difficult part, right? So how do you know if this thing, like if experiment tracking is more important than pipelines, right? You don't. And here, what you can do is you can ask for help your colleagues, or you can ask somebody for help. Like you don't always know, but you just go and ask, like, what do you think? Is this thing for our settings more important than that thing, right? And then using this, you kind of you come up with a list of skills that are ordered by importance, and then you pick the most important one and you practice. You put, I don't know, 3 days, 5 days into learning this, and then you learn enough to be good at this skill, right? And as I mentioned, don't be afraid of asking for help. It sounds obvious, but I know myself that I don't always do this. And yeah, it means just finding somebody who is sitting near you, like the product manager I mentioned, and then just talking to them. Like it's not necessarily a mentor, but somebody who can help you. But you might ask me, hey, but I don't have a mentor. I don't even have a job. Like, how do I go about finding a mentor? And then in this case, you can join a community. And in the community, you can just ask, like, I need help with observability. Can you help me identify what is the most important thing I need to learn to focus now to be independent in this? So then you can just join a community and find a bunch of mentors there. So this is the end of the talk. Now I want to summarize everything that we covered today. So to be a more effective data scientist, you, in my opinion, like there are some career tips, we should be better at following MLOps principles. So this is like the engineering part and the processes part. And then also get more into the product side of things. Ask ourselves why I would do certain things. Like, will what we do benefit the end user? And with that, we kind of become the full stack data scientist. But this is too much, right? So we cannot learn everything, but we don't need to be experts in everything. So we can use this 80-20 rule to identify the things we need most. And then for that, we ask for help, we find a mentor, and we join a community. So that's all from me. If you have any questions, here is my contact information. You can find me on LinkedIn. You can find me on Twitter. You can also find me on DataTalks Club, which is a community of people who love data. So I hang around there. So you can find me there. And also, shameless plug, if you need to be able to identify, if you need help with identifying the 20% of effort in order to learn MLOps, we and DataTalks Club soon are launching an MLOps course. So you can just go to our website and see, or just Google ML Zoomcamp. So that's all from me. I think there is still some time for questions, and I'll be happy to take these questions. So don't forget to check the course, and I'll go see if there are questions. Yeah. So there is a question from the community. Can you provide some examples of technical debt that data scientists might encounter in their daily work and how to prioritize paying it down? Well, yeah, usually as a data scientist, I know that I am the biggest contributor in creating technical debt because data scientists are usually not software engineers. So the way we create code is not always the most optimal, right? So we often end up with creating messy notebooks or scripts that are hard to read. And these are the most common ones. So you get a messy notebook or a script that is difficult to do anything with. And so the way you prioritize it down is when you need to change something. So if it's working, then yeah, it's fine. But once you identify that there is an error, you don't just go fixing fix the error. Maybe you add some tests first, right? If there are no tests, or like, yeah, it depends. Like in more mature projects, maybe you already have tests, but maybe there is some other problems. So, and when you fix this problem, when you fix a bug, maybe you also pay a bit of this technical debt. So that's how I would approach it. Sometimes in the past, we also did these bug bashing sessions or technical debt sessions. There are some issues that have been around for a while and nobody wants to touch them because we're always busy, we're always doing some other stuff. But sometimes it's just helpful to set 2 or 3 days aside just to focus on this. And yeah, so you just get together the entire team. You say, okay, today we just focus on fixing the technical debt, fixing all these bugs that we have in our backlog. So just let's do this there. Now, there are other ways, I guess, too, but this is quite a useful one. So let's see, there is another question. How do you approach collaborating with business stakeholders who might not have a technical background to ensure that the work is aligned with their needs and goals? Well, by talking to them, I guess. It's like such a broad question. I don't even know how to begin. Here, I guess the tricky part is managing expectations, right? So sometimes the expectations can be unreasonable. They just expect that machine learning will magically solve all the problems. And here, the key in addressing this problem is educating the business stakeholders, telling them what machine learning is, that it's not deterministic, it has some accuracy, and what it means in practical terms, that sometimes the model will not be correct, right? And you can talk about things like precision, recall, and also the tricky part here is to convince them that it's okay that the model is sometimes not accurate, right? So this is not the end of the world. And then also think how exactly the follow will look like if there is a model outputs a mistake. Yeah, I think that's it. When it comes to that, yeah, actually, there's way more. Like I think we can just spend entire talk on that. Okay, I see that there is another last question maybe that I will take. How to write clean Python code? Any book recommendation? So there is a book called Clean Code. It's in Java, but I think you can find examples in Python. So check it out. And I think with that, I don't have time for any more questions. You can always find me online. And I think I'm also in the Arize Slack channel. So if you have any questions there, you can just tag me and I'll get back to you there. Right? Do you have more time or that's it? Yeah, thanks for joining the talk.